Hey folks, this is section 10.2. I'd like to just discuss with you briefly two things from this section. The first thing is the law of cosines, and then the second thing is going to be area of a triangle. So just want to give you the formulas for the law of cosines. Remember that this one is the one that's used when you're given either two sides and the angle between, or if you're given all three sides. So you see here that I have the first law of cosines written, and that's a squared equals b squared plus c squared minus 2bc times the cosine of angle A. Just a couple of things to mention on this, and that is you'll notice that whatever side I start with is also the same name as the angle that I use at the end. So if I start with side A, I'm using angle A. Side B, I'm going to use angle B, etc. And then the second thing to point out about this, just so that it will help you to remember, is that if I'm using the letters B and C in this piece of my formula, I'm also using those same letters B and C in this piece of the formula. So that should help us really easily come up with the other two law of cosine statements. So on that second one, you have B squared. So that means that I'm automatically using angle B at the end. And then in the middle, if I'm using b squared, then that means in the middle I have to be using the a and the c. So this is going to be an a squared plus a c squared minus 2ac times the cosine of angle b. And then for the third one, c squared, that means I have to be using angle c at the end. And that means I'm also using the sides a and b on the middle. So we have an a squared plus a b squared minus 2ab. One note, I actually mentioned this back in the 10.1 video. Remember that the law of sines is not able to find obtuse angles, but the nice thing is the law of cosines can. You remember that inverses find angles, and for the law of cosines, since I'm using cosine inverse, the restriction was up on the top half. Well, I have obtuse angles in the top half of the circle. But if you think back to the sine inverse doesn't use any obtuse angles. It only uses positive angles from 0 to 90, and it uses negative angles from negative 90 back up to 0. So the law of sines cannot find an obtuse angle, but the law of cosines can. Now, if you go down the page to where you have the area of triangles, finding the area of triangles. Of course, you learned in high school that the area of a triangle is 1/2 base times height. Well, I'm going to give you a couple different versions of area depending on the kind of data that you know. And we're going to look simply at the side angle side version and the side version. So if you're looking for the side angle side area, you know you have a triangle. You have two sides and the angle included between. This is going to be, the area is going to be 1/2 side A times side B times the sine of angle C. Now you notice I'm getting all three of my letters in here. These right here are the two sides that I was given. And then this is the angle that is between. And you say, why did you draw a fancy A over here? Simply because I did not want you to get that confused with my angle A. So the fancy A is more for the area of a triangle. Now, I'm not going to write all of the versions. Just understand that these are the two sides that I'm given, and this is the angle that's in between, regardless of what the letters are. So we'll be switching out those letters occasionally. The second type of area that you're going to be looking at is when you have all three sides given. And here you're going to use something called Heron's formula. This is a two-step formula. The first thing that you're going to do is find the semi-perimeter. You already know what perimeter means. That's just where I take my A plus my B plus my C. I add up all my sides. Well, semi-perimeter is half of that. So I'm going to add up all my sides, A plus B plus C, and then I'm going to take that sum and divide by 2. That's the semi-perimeter. Heron's formula uses the semi-perimeter. So you have area, again, that fancy A, is equal to a big old square root. And then inside the square root, you're going to have the semi-perimeter times the quantity semi-perimeter minus A times the quantity semi-perimeter minus B times the quantity semi-perimeter minus C. And this will give you the area of a triangle when you only know the three sides.